Good morning, everyone, and welcome to our Turnkey Projects webinar. Today, we will be looking at turnkey projects. So that's where ACE can offer a bit more than just simply the supply and installation of a single product, but where we go on to supply whole projects. So that can, of course, include various services such as surveying, three-dimensional drawing. It can include ancillary products such as actuators, hydraulics, those kind of things. We're going to go and explore what we can do, what we can offer in terms of providing a whole package. Quickly to run through who ACE are. We were established in 1995. So we've been in operation for 25 years now. We've been in the game controlling water and helping fish migrations for a long time. We're a very innovative company. We were the first in the UK to offer HDP and stainless steel water flow equipment. That's really where we started. But we've grown since then to also offer various fish passage solutions and other products and services, many of which are based on very innovative solutions to problems. We represent various Dutch companies, with the Netherlands having 1/3 of its whole landmass and almost half the population living below sea level. Schiphol Airport, for example, is 7 meters below sea level. They really are world leaders at controlling water and preventing flooding. That's why we go to Holland to see what the Dutch are doing, explore how they're tackling these problems, and introduce some of the solutions to the UK. Our vision is very clear. We want to protect people, property, agriculture, everything that the flood defences protect. However, we really don't want it to be damaging our ecosystems, and therefore we like to offer that ecosystem solution as well as providing the flood defence. So really, you don't have to compromise. You don't have to choose between the two. We have some amazing compromises and solutions to ensure good fish passage whilst being able to regulate and control your water. So, of course, when it comes to turnkey solutions, you need to know that you're working with a well-accredited company to make sure that they have all the quality systems, health and safety systems in place. Of course, the health and safety ISO 18001 speaks for itself. It's a very prestigious particular accreditation. But don't forget our 14001, which is from the environmental, and the 9001, which stands for the quality. We also have UVDB, which is for the utilities vendor database, which covers mainly for the utilities industry, but they check us out as well. And we're a member of Construction Online, which is mainly for the tier 1 contractors to see very quickly, get access to our insurances, everything that they can to check us out and make sure that we're a bona fide, or we are the bona fide company that we say we are. So we can manage, and today I'm going to basically show what we can offer, everything going from small projects where it might just be the installation of a couple of penstocks, as you can see there, and some control systems and keeping it fairly simple, and then move all the way through to some of the biggest projects that ACE have carried out. I think the nicest way to show what we can offer is to show you exactly how we use the services and our capabilities to deliver really some very impressive projects. I'll actually hand over this slide to James. James is our technical director. Hi, James. Can you hear me?
Yeah, morning, Martin. Morning, everybody. Yeah, I can hear you. I don't know whether you can see me.
You're on mute, I think, James.
I've just unmuted, so I should be there. Can you hear me? No, you can't hear me, Martin, I don't think, can you?
Yeah, I can hear you. Sorry, I was my microphone was off. Carry on.
Okay. Excellent. So, basically, Martin's handed over to me just to have a go through what we do in the operations team. But basically, this covers a lot of our more site-based things and more to do with the project-based things. But we do have a dedicated team of site staff that look after everything from surveys in and out of the water, also confined spaces and that sort of thing. We also do design work, which incorporates quite a lot of 3D modelling, that sort of thing. So we often come out and we'll survey your site. We'll then draw up a structure of your site and then actually produce drawings with the products shown on them. So not only do you get a really nice standard drawing with all your dimensions and everything, but also you get a 3D render and that sort of thing to show you exactly what it's going to look like when it's finished. I do have a couple of examples of the 3D modelling, of the 3D scanning that we've done, Martin. Do you want me to demonstrate that now?
I think we'll wait until the final project, because that's what it's for.
That's
which
fine.
is
Yeah.
currently the biggest project that Ace have worked on. So I think
Okay.
we'll come back to that.
Yeah, that's fine. But just to cover a few of the sort of typical skills we've got, I mean, we do have NEBOSH trained site managers. We also have all of our site team are confined spaces trained. We also have water safety training for water rescue. They're all face fit tested as well for the dust mask and this sort of thing. We have quite a heavily involvement on the sites, and that includes things like lifting. We have asbestos awareness and all the necessary sort of safety qualifications that we're going to need for any kind of work that we carry out. Okay.
Yeah, no, that's great. So as I was saying, we're going to start off going from the smaller type projects all the way up to a current live project, which is the largest one that Ace has ever been awarded. To start off with small, Crown Paints. Now, Crown Paints is a local, I mean, they're based in Hull, manufacturer of paint. And whilst they're producing paint, they produce various chemicals that they do not want spilling into the environment, particularly ammonia. So ammonia is a byproduct, and it's one that they contain and they ship off to be dealt with elsewhere. However, in the event of a fire, what you might have is the fact that the ammonia drops into their drainage system and could be leaked out into the environment. So they wanted a solution to prevent that. So we got in touch with them and said, look, we can offer a product which is pretty much ammonia proof. Stainless steel 316 does not react with ammonia. HDPE does not react with ammonia. However, what will react with ammonia is, for example, polyacetal, which we use for our nut blocks, or even phosphor bronze, which is an alternative material we use for our nut blocks. So what we did was say, rather than having the spindle block underneath or inside the pit, inside the chamber, we can use a rising spindle, which is therefore on top of the actuator in a spindle tube to keep all the materials which would react with ammonia above the surface. So really, really great solution. The Crown Paints decided that they were going to, well, they needed a new manhole. And this also goes with one of our rules of thumb. If the civil works is worth more than the product, then generally we'd like to just supply and install the product. However, if the product is worth more than the civil works, we will take on some minor civil works. So that's how we kind of see it. So in this particular one, because it's a new manhole, we left that to a local contractor and we supplied the goods. Now, of course, it had to operate with the fire alarm. So when the fire alarm triggers, the penstock valve shuts to make sure that it's penning and holding all the ammonia within their catchment, within their draining systems. So you can see we also supplied the panel that operates it and ties the whole thing together. So the penstock's open, fire alarm goes off, panel is activated, penstock drops shut, and it doesn't come back open until somebody interacts with the panel to open it up. Neat little solution, not a huge project, but it does show you what we mean by turnkey. You know, there's multiple things going on here. Wattenbeck. So Wattenbeck is on the River Hull, yeah, also in that kind of area. It's very close to Wilfholme Pumping Station up there, which is an Environment Agency asset. And this is a drain that runs past that pumping station. Now, what they've got here is on the other side of the asset, there are two flap valves. However, they have problems with them silting shut. They have in the past been using excavators to remove the silt that builds up underneath the bridge. However, they found that there's lamprey there. Now, lamprey are endangered species, so they don't want to be disturbing them too much with excavator buckets and things like that. So they wanted a way which would help flush the culvert out without causing any damage to the lamprey. We, of course, came and had a look at the site and said, well, it's quite easy to put some penstocks on there. And by putting the penstocks on there, you can close them. You can let the water level in the drain build up. So it's a bit higher than what the River Hull is. Then crack them open. And because of that head difference, you're actually forcing much more water through the culvert, which would then help move and dislodge all of the silt without doing any damage to the lamprey. Customer thought it was a great idea. This was installed, I think in 2014, and we've had absolutely no complaints. It seems to be working really, really well. But of course, when it comes to installation, as you can see here, you've got multiple ways that you can approach it. You could set the whole site dry, but that's really quite expensive and quite an undertaking. Or you can do what we did, which is engage with divers. So we used divers to be able to install these penstocks underwater. Now, divers aren't cheap, but a couple of days of dive work is still a lot more cost effective than building a whole cofferdam to try and set it dry. And this is a typical kind of package that ACE will pick up. Penstocks, provided with a problem, put forward a solution, and then offer it as a full turnkey package for installation. This one is a Port of Tyne. So Port of Tyne, very similar scenario. They approached ACE with a challenge, also to do with their fire alarms. So Port of Tyne, they basically have a new contract, or they had a new contract at the time, to supply biomass pellets up to Linemouth Power Station. So with these biomass pellets, they need to be able to store large volumes of them. And the risk is that if there was ever a fire, that these pellets would fall into the drainage systems on fire, potentially with chemicals and other things, and float into the River Tyne. So, of course, they wanted an emergency system linked to the fire alarms to make sure that if there was a fire, the penstocks would fall shut, pen the water and any flammable materials or chemicals that had leached into the drainage system within all of the drains. The problem was they also need a non-return valve on there. And the reason they need non-return valves is because every tide, of course, the tide comes up higher than the level that they want to be maintaining in their drainage system. So they need non-return valves to prevent the tide from being able to come in. But there was not really space to put a penstock somewhere without major civils to create large new manholes and things like that, as well as putting flap valves. So ACE came up with some solutions for them, and that's a combi product. As you can see here, this is a penstock and flap valve, which are being combined. So you've got the best of both worlds. In normal day-to-day scenario, the flap valve's just operating. However, when there's a fire, the system triggers the actuator that's been mounted to the penstock, closes the penstock. So, of course, then you are penning any materials that have entered into the drainage system. You can see from the image sort of second on your right, that also the installation was quite tricky because the outfall is literally on the edge of the harbour. So we also worked with divers on this one who've got all the marine plant and, as you can see, small boats to gain access to make sure we can get to this. As principal contractor, it meant that we did all of the CDM, we provided the welfare facilities and took on this whole package. So mechanical, the installation, also electrical. With the electrical, you'll see this on the second penstock. There were 6 different sites here, by the way. It wasn't just the big pen flap. You can see here another manhole we designed a special penstock for. It was quite a tricky penstock because there's nothing on the far side on the headstock, so we had to be able to capture the forces in various ways to be able to make that work. Once the lid was on, or the biscuit, you can see the pedestal that comes through, and then once again the control panel, which is of course linked to the fire system, which triggers the actuator and makes it move. Now, to explain the other 4 penstocks that we did for Port of Tyne, you first need to understand the wire stop. So the wire stop is a type of non-return device. As the pressure builds up behind the valve, the polyurethane membrane pops open, creates a nice flushing flow, keeps all debris and silt and everything out, and obviously lets the water out. When the head on the downstream side is applied to the valve the other way, it holds it shut, stops water coming out. However, if the upstream level once again becomes higher, it will open also when it's submerged. So it's a check valve. It's a non-return valve, just a clever one. Now, what this allowed us to do was, on several of the smaller penstocks, is rather than providing a penstock flat valve combination, we could supply a penstock wire stop combination. So you can see here, we made the wire stops with a special flange so that the fixing eyes were in exactly the same place as on the penstock. So of course the fixings could be driven all the way through, and you basically sandwich the wire stop nicely behind the penstock. Now, these were very challenging little penstocks, firstly because we needed to do some civil works. So you can see here, minor civils, we had to break out this channel to enable us to actually mount the penstock. But all of this had to be done underneath the quay. So the Port of Tyne quay is literally directly above this penstock. There's forklifts moving there, lorries, trucks, cranes, you name it, it's going over the top of that quay. So they also were very, very keen not to have a spindle coming through the top of the quay and having pedestals and things like that above the surface for these particular ones. Now, we've been working with Alma for quite a few years, and they had a new product, which is now tried and tested by ACE, of course, but for a submersible actuator. So this is an actuator which can operate whilst underwater. We use these on all 4 penstocks. They've been installed since 2017, so a couple of years now. And they're operating perfectly. They've all got marine grade coatings. They can operate while submerged up to 8 meters. These will never be submerged more than 3 or 4 meters. And the motor is separated from the controls. So normally with an actuator, you've got the motor and controls all linked together. But here we have the motor, which is sat on top of the penstock, and the controls, we can then pull with an umbilical cord, the cable through the duct, and put them above the surface in a location which is easy to get to. That, of course, could then all be linked back to the fire system, so that when there's a fire, the actuators all trigger, closing the penstocks and completely isolating everything. So, more challenges for ACE. Loch Duntelchaig. So this is up in Inverness. Now, the situation here was that Scottish Water require both Loch Duntelchaig and the next door neighbouring loch, Loch Kinchy, for drinking water. The drinking water is basically provides all the, from these 2 lochs, provide all the water for the population of Inverness. So they're crucial to the supply. However, they also need to make sure that they've got maintain a minimum flow down the river, so over this weir and down here, to satisfy SEPA, to make sure that their hands-off flows are being controlled, and they need to be able to maintain fish passage between the loch and the watercourse, which originally was attempted with this structure that you can see on the left. The problem with the structure as it stood when we arrived was, it was all concrete and non-flexible. Because it's not flexible, if the loch is too high, absolutely tons of water is going through this fish pass, which no fish can possibly swim against, and is also, to a degree, a waste for Scottish Water, because that's all drinking water that they're potentially losing. On the other side, if the loch is low, so below that weir level, then the fish passes dry. Fish still can't pass up it, but then Scottish Water have also got an issue in terms of their hands-off flow, because they're not meeting their obligations in terms of providing the flow that has to be able to maintain downstream. ACE were engaged as M&E contractor on this one, so we delivered a full mechanical electrical spec, and you can see that there was tilting weirs is how we created the solution. So with the tilting weir, we included a V-notch with an adherent nape. So the adherent nape is to help the fish go over. The V-notch is actually there to make sure there's a calculated flow, to make sure that always the minimum flow rate is passing over them. And the way it works, if you see all of the weirs stood in their vertical position, that is, of course, when the loch is completely full or higher than, and water will just spill over the top. As the loch levels drop down, so does the top tilting weir, until it's level with the second tilting weir, in which case it goes and lies completely flat, and the second tilting weir becomes driving and operates and carries on the level until the water drops down, of course, passes it over to the third. Now, the challenge on this site was power. So they looked originally at installing some three-phase power, but it's a long way from any kind of any power supply. So they were looking at upwards of 140,000, I believe it was, really large sums of money to install power to this particular location. Now, the problem that you have with a normal actuator, such as a Rotork or an Orma, is that they aren't actually that efficient. They've been designed principally for the gas and oil market. They've been designed to be explosion-proof, extremely robust pieces of kit. However, on the downside, what you get is a huge amount of friction. And if you ever hold a Rotork and you try and turn a nut block by hand, even a smaller one, you can't do it. And that just shows how much friction is built into these products to make sure that they are literally bomb-proof. But that also means that they need a huge amount of power, respectively, to operate, which means that trying to operate them through solar systems, for example, becomes very expensive because the array that you require becomes absolutely enormous. So what we did is we engaged a partner of ours called CB Flavorland, who produces these green boxes. So these green boxes can be manufactured up to 30 Newton meters. It's not a great deal of torque, but on a tilting weir, you don't need a lot of torque. And the reason for that is the side cheek of a tilting weir, it's a quadrant. And on top of that quadrant, you've got a small pinion wheel. So if you imagine the gearing ratio, if you turn that quadrant into a full circle, the ratio between that quadrant and the pinion wheel is enormous. And that means that you need very little torque to actually operate a tilting weir. And that's where this product comes in. It's a lot lighter duty than say a Rotork or an Orma, but the nice thing is it's got everything in its own little box. So it's not just a solar powered actuator, but it's also got a 3G SIM in there, and it connects to an online portal, so you can steer it, you can program it, you can set it all remotely, you can watch it. It's got its own level sensors built in, so it literally is its own mini control panel cum actuator. So for ACE supplying 4 of these to operate the 4 tilting weirs at this particular site, we saved Scottish Water an enormous sum of money and provided a really, really great fish pass solution. So it's a project that we're very proud of. Kinloch Leven. So also in Scotland, at Kinloch Leven hydropower, so that's the Blackwater Dam. One of the oldest. It was built in the Victorian times. To be honest, a great site to go and see. All the Victorian engineering is there. You've got the old mechanical devices that have been used to control the flows. Really fascinating location. But at this particular hydro site, they have the main body of water coming in from Blackwater, which is this large storage water at the top. However, they also have 4 burns. Burns is the Scottish for a stream or, small river. And these 3 burns could all add water into the system. So you had one main conduit, which is a big square conduit, which linked the dam to the hydropower station. But along that long conduit, there was another 3 individual small conduits that could also add water to it. Now, what that means is when it rains and these burns are full, they don't need to take water from the main reservoir. So they can store that for summer. They can keep all of that as much as possible and run it purely off the rainwater that's coming in through these burns. The problem that they had was that there was nothing at this site to regulate the flow except the old Victorian equipment, which had all seized and, well, to put it another way, there was a small chair next to one of these pivoting floats. And I asked, what's that for? And the customer said, oh, well, you know, before it became economically unviable, we employed a man back in the 70s to sit here and watch. And every time the equipment stuck, the man would just go and jump on top of it, this counterbalance, to open the plunger back up. Of course, that's not economically viable, and they stopped using these 3 additional water courses. They needed to open them back up because it makes the whole plant much more efficient, means that much more energy is being produced. But to do that, they needed to be able to control the flow going into the conduit to make sure that it's not overtopping or getting a surcharge. And to do that, you need penstocks. So ACE supplied the penstocks and talked about how we could use the penstocks to regulate the flow. So they're basically modulating penstocks. They move up and down, and they're linked to a level sensor, which is close to the conduit. So as soon as the level comes up too high, the penstock closes to throttle the flow. And as soon as the level drops too far, the penstocks open to get more water through. Now, that's all great, but penstocks do have a slight risk in terms of debris getting clogged. Not only the penstocks, but also the hydropower equipment has problems when too much debris gets through it. So as I was there, I was asking the client, you know, is there a problem with debris? Because I can see these old screens, and they literally were old screens with all of this moss and different materials sat in it. I said, yeah, no, we have to send a man up if we're going to use this on a regular basis. So I introduced him to the concept of the back raking machine. So as you can see, we'd supplied the penstocks, so 3 penstocks, 3 back raking machines, the automation of the back raking machines. They also work on a level differential. So as soon as the level is different on either side of the screen, the machine knows it's blocked, turns itself off, on, and these rakes come up and flick any debris over the top. And then carried out the full installation of all of those items as well. It seems to be running absolutely beautifully. We've got a very happy customer up there at Kinloch Leven Hydro. So ACE can also act as as you've seen from the River Tyne, but we can act as full principal contractor for some larger projects as well. On the River Wissey in Norfolk, we installed the UK's first fish siphon. So fish siphon is a product that raises water from the upstream level up over the siphon and lowers a bit back down. It's using basic siphoning technology. However, what we do within the siphon is supply a series of baffles, and these baffles all have notches cut out of them, so you create a pool and weir type fish pass within a pipe. As you can see here, this allows fish to move upstream and downstream, and also it's much less species dependent than typical Larinia passes, which are only really for the strong swimmers, or pool and weir type fish passes, which some of the weaker species might not choose to go through. This seems to be passing a wide variety. So the problem that we had on the River Wissey is you've got the main Wissey that comes down through here. So I'm showing with my mouse. And you've got the cut-off channel, which goes underneath the Wissey through an aqueduct. Now, you've got 2 sluicing complexes, which keep the level differences. So the canal level is much lower than the River Wissey. However, in times of storm or when the Wissey looks like it's going to burst its banks, you can open the sluice gate, relieve the Wissey by using the canal system as storage. The canal system is connected in King's Lynn to the sea with some big lock gates. And what the problem is that a lot of sea trout are coming into the canal through these lock gates and becoming trapped on the River Wissey. And it was quite obvious how bad it was, because this sluice, which connects the Wissey to the canal, leaked significantly when we were there the first time. And the sea trout were just jumping at the door, trying to get through, because a canal system is not ideal habitat for them. The Environment Agency had already looked at using traditional Larinia type fish passes and things like that, but the costs were astronomical. And that's because there's a lot of concrete, civil works, everything else that goes into it. And it just wasn't economically viable to put a solution in. So ACE came and had a look at the site and said, well, our fish siphon, you can put it, in an L shape up and over the flood defence, so you're not taking a big notch out of it. And you don't need that much civil works. It's essentially like laying a big pipe. You have to dig a trench, put a bit of aggregate in the bottom of it, lower the fish siphon in, bond the fish siphon on site, and then backfill. And then there's very simple controls with a small vacuum pump, just to make sure that when the water levels are dropping in the siphon, you can draw a vacuum and raise it back up. So our solution was, I think, a quarter of the price of the Larinia type fish pass. And ACE were awarded the full contract by the Environment Agency as principal contractor. So ACE organised all the logistics, craneage, lifting, earthworks, the whole project. And it's one that we're very proud of, being the first fish siphon in the UK. You can see it's not small pieces of kit. This was a 1.6 metre diameter pipe, which was over 70 meters in length. And the end result was absolutely fantastic. Like literally days afterwards, a sea trout bolted out and straight into the fyke net. The customer of this particular site was sat fishing when that happened. He'd just caught an eel and he looked over on the right and saw the net flying all over the place. And that's because this sea trout had gone in it. So really, really great results. Want to look at some slightly more complex projects. Appledore pumping station, for example. At Appledore, ACE were engaged by a tier 1 contractor. End client was the Environment Agency, and we were engaged to supply the full mechanical electrical package. So that was to supply not only the pumps, but also control panels, non-return valves, and in this case also do some CFD modelling and provide FSIs. Oh, just quickly on the map, if you didn't notice, Dover's over here. You can see Tenterden. So this is in Kent, near Romney Marsh, an area where there's quite a lot of land drainage happening. The original pumping station was operated by a single-cylinder heavy oil motor. So that in itself, the fact that we're still using that in the 2010s is remarkable, really. And I mean, that machine has gone to a museum. This is the museum. But yeah, it's also not particularly great when it comes to a carbon or efficiency perspective. Of course, heavy oil is not particularly great in terms of the amount of CO2 it releases and other chemicals. But also it's not particularly efficient. A single cylinder engine is operating at a single speed. And when a pump is operating at a single speed, it's most of the time not operating very efficiently. However, the pumping station was being operated by this and the impeller would sit inside the building. So it's an end suction pump. What that means is that the impeller, rather than being underwater, is inside the building and linked to this motor. So first you have to create a vacuum, draw all the water out of the pipework before you turn the pumps on and get the impeller operating. And the benefit of that system is you need a very shallow sump. You don't need much depth in there at all, which of course saves you from digging a large amount of earthworks. Now, originally during the tender, the project was supposed to be awarded to our competitor. However, we challenged this because we said, well, how are they doing it? Because the impeller submergence needs to be, on those particular pumps, at least 900 mil. And there's no way that's possible because the pump sump is not deep enough. So they're either raising the water levels 500 mil, which you can't do. Anybody who works for the Environment Agency or with land drainage or for internal drainage boards can tell you, you can't just overnight, yeah, we'll just raise the levels by 0.5 meter because it's going to cause all sorts of issues? Or are you completely breaking out all of the sump and digging down and digging deeper, which is coming to huge costs? So the Environment Agency did do some checks before they formally awarded it and realised, yeah, that the offer wasn't going to work. So they asked us, do you have a solution? We said, of course we do. We can do all sorts of modelling and work out how we can create a formed suction intake that's going to work. So you can see here, this is what I mean by the CFD, computational fluid dynamics. We could model the whole pump sump, how the water was going to enter the pump, make sure that the impeller, it didn't matter that it wasn't submerged so much because we're making sure that all the water that's coming through isn't carrying any oxygen by creating this FSI. And it's something that our pump partners, Pentair, are particularly good at. The factory where the fish-friendly pumps are made is Pentair's global centre of excellence for CFD modelling. And the fact that we do the modelling in-house, whilst many pump companies, they would subcontract this out to a CFD company, means that we're much more comfortable to go to tighter tolerances than what a consultancy would do, because obviously they've got to also protect themselves and they have less interest in the project, should we say, so more interest in caution. We have more interest in the project. Of course, we don't want it to go wrong, but also the risk balance is different, and therefore we're able to explore the tolerances tighter and be able to offer really, really, really good solutions, such as this one at Appledore. So you can see on the left, the CFD modelling was done. We were very comfortable. We didn't even feel that we needed any models doing to double check because the tolerances there was plenty of space for margin for error. We could then fabricate the FSI, the formed suction intake, which you can see here. And then we put the pump canisters on top, inserted the submersible pumps, and then also, of course, supplied the full control panel, complete with ABB variable speed drives. And it's very important with the variable speed drives for fish-friendly pumps, because if you go with a fixed speed drive, what you end up with is a pump that's not running as efficiently as it could be at all moments in time. Now, fish friendliness with the fish-friendly pumps is in direct correlation to pump efficiency because you get the most smooth laminar flows going through the pumps when the pumps are operating at their most efficient point. So the efficiency is a win because, of course, saves energy, reduces CO2, but therefore it also has a secondary win in terms of improving fish passage. So yeah, A supplied the variable speed drives, control panel, full electrical installation. And then on the outfall, we supplied a flat valve and the wire stop. So once again, combination product. Now, the benefit of doing that is the fact, normally in a flood defense, you need 2 lines of defense. So with a pumping station, what you typically have is either a siphon with a breaker, which in itself is very strong defense, so you don't necessarily need a knife gate. Some of them do, but this was a pump with where the pipework went straight through. So you need a flat valve, non-return valve, and typically what you'd install is a sluice gate or a knife gate. Now, with a knife gate, the issue that you have is then you've got an actuator, you've got moving parts, you've got extra equipment that needs maintenance, lubrication, and you've got to steer it. So it's got to be linked into the control panel. It needs controlling so that it's opening before the pumps are starting, and it's quite complex. So by introducing a wire stop rather than the knife gate, it means you've got 2 passive non-return devices, neither of which needs any maintenance, neither of which needs any kind of automation. So really, really excellent solution, which the Environment Agency also feel is much more robust and economic over the long term. Whilst we're on site, our technical director, James, found a ferret. So we're not just doing work, we're rescuing animals at these projects as well. Now, Camden Lock is a recent project ACE delivered as principal contractor for Waterways Ireland. So we're not just operating in the UK, but we're doing more and more projects across the Irish Sea. installing various pieces of kit, but this is one of the major projects we've done recently in Ireland. So ACE were, as I say, principal contractor, so we're responsible for the whole project. We engaged with divers, marine equipment specialists, of course, with our partners to produce the flow control. We carried out the full survey, and then also the existing rebates were in poor condition, so we also carried out the fabrication and design of the stainless steel rebates, setting them out, casting them in, lowering the stop logs in, using marine plant. There was no real plant space on the side of this, as you can see when it zooms out on the right, for any crane to be positioned, so it had to all be lifted from the water. And the end result is brilliant. I mean, a set of stop logs 12.5 meters wide, 6 meters high, that's been installed in a U-shaped channel to seal to this degree. Yeah, that's something that our customer almost couldn't believe when he saw it. So very, very satisfied, and we were very proud of what we did there as well. So Laxton and Blacktoft pumping stations. Yeah, ACE acted as M&E subcontractor to the principal contractor who did all the earthworks and concreting. I know you're thinking pumping stations, why am I looking at flat valve? And that's because we took on the M&E project. And part of the M&E was also this large non-return valve. So all the way down the Humber estuary, you've got a series of old wooden pointing doors. And these wooden pointing doors they're getting to a place in certain areas where they should be potentially replaced. This is the second that we've done. We're currently engaged in a contract to deliver another one, but we remove all the timber. The base of this structure is also wood. Install a concrete plinth, so some minor civil works. Carried out the design of the gate. You can see here the big stainless beams that are holding it against the sea. Install the cofferdam to make sure that at high tide the water isn't coming in. Lower everything into position, fix it. And the reason I've got the nice photo of the guys who put this in on the right is because when you look at the picture on the left, you can't quite grasp how big it is. But when you look at the hinge position, which is running through here, and where their helmets are, you can see these really are sizable pieces of equipment. Also at Laxton and Blacktoft, there were, of course, 2 pumping stations. Each pumping station had 2 pumps. So we delivered in total 4 pumps, 2 kiosks, 2 control panels with our local partners for this particular project, carried out all of the lifting for the mechanical, electrical items, lowered in the pumps, fitted all of that. So yeah, full turnkey with the pumps, control panel, non-return valves, yeah, the works. It ended up as a very neat installation, as you can see here. The only thing which we had to change, which was quite funny, was the powder coating. So you can see on the specification, they asked for Scotch coat. Now, Scotch coat, as many of you know, comes in one colour, so we didn't really need to ask. However, on site, yeah, turquoise wasn't really what they were going for. So they asked us to just quickly paint the caps and make sure it all tied in with everything else nicely. Those pumping stations are operating brilliantly. The recent floods that they had, the Ouse and Humber Drainage Board are convinced that it would have been far more serious had it not been for the installation of these 2 assets. So overall, excellent project, really happy bunch of people. It was opened by NFU. That's about as famous as we get in the land drainage world, but yeah, they thought it was an excellent project. So then we come to Bells and Mockets. And Bells and Mockets is on the Isle of Sheppey in the Medway estuary, so just to the east of London. And this particular project was a combined funded project from the Internal Drainage Board and the Environment Agency. So the Environment Agency had 1 pumping station called Mockets, and the Internal Drainage Pumping Station, Internal Drainage Board had a pumping station called Bells. Now, the project was to combine both these pumping stations, and they wanted to make it as fish-friendly as possible. And also, the client had experienced a lot of problems with, believe it or not, eels, but also other debris getting clogged in his submersible pumps. and therefore he was having to remove them quite often, take them apart, put them back in. It was a maintenance nightmare. So he wanted something which was going to have the least debris issues possible. So we recommended the Archimedean screw, big 2.5 meter unit, 2 of them to meet the 3.5 cubic meters per second capacity. And therefore, because it's operating and it's slowly and it can pass really large debris, it solves that problem, but also it's an extremely efficient solution. You can find out more why if you look at the recording of our pump presentation. Let me know, by the way, if you do want any recordings of previous webinars. We've recorded them all. And also, please do feel free to ask any questions. If you've got any questions, you can type them in the Q&A box on your left-hand side, and I'll respond. So this particular project, we weren't just engaged for the pumps, but we also delivered that whole kiosk, completely bespoke kiosk for this project, and installed the control panels, the non-return valves, the stop logs. So once again, full turnkey M&E. We also did the lifting of the pumps, as you can see in this image here. And the end result was fantastic. We ended up with this really nice project. I'm sorry, I've just been distracted because somebody's strimming outside all of a sudden. So this whole project looked really smart, really sleek. You can see from the nice building how everything was put together. You can see here with the flat valves that they're operating. With a fish-friendly pump, it's always important, by the way, to use HDPE flat valves. If you don't use HDPE, it's too heavy, and what happens is the fish comes out, bangs its head. HDPE moves nicely out of the way, and you create maximum room for passage. Just got one question. Nope. Sorry. You can see the overall solution here, which was nicely captured by a drone. So it's another project for us. Total project value was about 600,000. And that included for the 2 Archimedean screw pumps, the control panel, the kiosk that sits on the top, the 2 non-return valves, and the stop logs on the inlet. It's a large, significant site, one we're very proud of, and one where we take quite a few customers to come and have a look for the future. Before I go to the next project, which is Pembroke Power Station, I just want to touch on what ACE can do in terms of our engineering capabilities. With the penstocks and flat valves, any of the stainless steel products, but also the large products such as the stop logs, we can offer different degrees of engineering. And really the engineering, how much do you want to spend on it, is relevant to what is the risk. If the asset, for example, is protecting some arable land, you might say, yeah, no, trust the engineer, he's going to build enough safety in for it, just design your usual spec. However, where you've got critical assets, houses are at risk, people's lives are at risk, then you need to know that the engineering is being done correctly. So we can do engineering up to EN 1993, all the calculations carried out in accordance to those Euro codes, consequential class 2 or 3. So to give you an idea about consequential class 1 is, for example, typically for an arable building, or the risk of life is extremely low. So you might have one person in an arable building, a barn, for example. CC2 is that the risk of life is moderate. It could be that 1 or 2 properties would go underwater and it becomes quite serious. CC3, you're talking major calamity if there was to be a problem. For example, football stadium. If one of those was to collapse, a lot of lives would be at risk. And then there is a consequential class higher, which is 4, but that tends to be for nuclear kind of projects. So really major calamity if there's an issue. Now, these consequential classes and how you choose to design between each one is quite important to choose. For example, recently our partners KWT were awarded a contract to supply some tilting weirs, which protected a town which was about 4 or 5 meters below the tilting weirs. So the Dutch government insisted that it was to CC3. Now, what that means is that you have to model all of the equipment with finite element method to make sure that you're staying within the material's designated yield strengths, which in this case for stainless steel is 2.09 displacement, millimeters displacement per millimeter squared, or kilonewtons per millimeter squared. However, we actually use much stronger stainless steel. So the rules are written in a very prescriptive way, which tells you exactly how you have to design the product. And for CC3, that would be for 50 years. So you have to consider frequency analysis. So tides coming onto the product, going off for a 50-year cyclus. And for CC3, 100 years. Now, we're one of the very few, if not the only flow control manufacturer of stainless steel products that can offer this service. We do have to price it separately. It's not standard because otherwise we'd price ourselves out of the market. But it is something that if you categorically need to know that the product is going to be 100% safe and just trusting the engineer's abilities and experience is not enough anymore, that's where we are able to engage with the Euro codes, make sure that we do the finite element method, but also we can follow that through into manufacturing, where we've got really high welding standards and other European norms that we can stick to make sure the whole process is followed from start to finish. Including external non-destructive tests on the weld, external Cat 1, Cat 2 or Cat 3 tests that can be carried out. So you name it, you set the rules as the client, you tell us how critical it is. We can help put forward an engineering solution to make sure that everybody is completely confident and you're not just relying on an engineer's experience alone, but you're relying on very prescribed set of rules which tell you exactly how this must be calculated. So, Pembroke Power Station. The reason this is nice to follow up with the engineering is it's not just about being able to prescribe and make sure that it's 100% strong enough and with the frequency and everything. Engineering is also about innovation. And the innovation is something that ACE is really, really keen on. At Pembroke Power Station, the situation that they had there was warm water was flowing out of the power station. It whirred over into the sea. And as this water was waterfalling, if you like, into the sea, it mixed the hot water with the cold water, but also added air into the mix. Now that created there's a bacteria there present, and that created a foam. And this foam was literally meters deep. It's not particularly bad. It's a biological foam, completely natural. However, in a triple SI, which is a particularly sensitive area of natural beauty, the power station wasn't particularly popular for producing this foam. So the Environment Agency, or NRW over in Wales, basically instructed the power station, said, you have to solve this problem. We can't have this foam. Initially, the easiest way to solve that is extra cooling towers. But at £15 million a cooling tower, that's a very expensive way to solve the problem. So they thought there might be something they could do with water, and they engaged with ACE. So we said, if you put big penstocks in the front, and rather than the water whirring over the top, we can send the water underneath, then we remove air from the equation, and therefore we should also be able to remove a lot of the scum and the foam that's being created. So they thought it was a great idea, took our idea, put it out to tender. We weren't particularly pleased by that, of course, as many people understand. However, it gave us a new opportunity to look at the job, and we started to realise, after talking with these guys, that their loss of earnings at £100,000 a day was actually much more significant than the cost of the project. So it was all about doing the project fast, rather than doing the project cheap from a capital perspective. We noticed on site that there were some rebates, and these rebates were used for stop logs. Now, looking at the rebates, we could see, wait a minute, that's something we could potentially put the penstocks in. That would prevent all of the sheep piling, that would prevent all of that dewatering activity if we could just lower them in. But we do need to come up with a solution to actually jack them in place. So we created these jacking bolts, which you can see here, and they were connected by a spindle. So each one's a gearbox with a spindle running through. So as you turn the spindle, these jacking bolts wedge out. What that meant is that ACE, as principal contractor to RWE, we could work with divers, clear those rebates out, lower the penstocks into position, and I do mean penstocks, there were 6 of these, all 4 by 4 meters, 12 meters water column, like serious units. And we could drop them in, jack them out, and therefore they would be fixed. We then worked with an electrical contractor that we've done a huge amount of work with, one of the more trusted, or most trusted ones that we have, who built the control panels and did all the electrical cabling and everything else under our instruction. So really, really nice turnkey solution. Morpeth. So Morpeth is the biggest dam, and we call it a dam. The Environment Agency don't necessarily like that term, but it's a flow regulator. It's the biggest one of its kind in the UK. The principal contractor on this project, as you can see, had serious earthworks to be doing. Their focus was on huge amount of concrete, huge amount of earthworks. They had to divert the whole River Wansbeck around this asset during the construction time. So the last thing they want to be doing is managing 10, 15 different mechanical electrical contractors on site. They were just hoping, can we find a party that we can trust to take on the full M&E project so we can focus on the earthworks and the concrete and know that that's in safe hands, being completely managed by a single party. ACE, of course, were more than happy to work with the principal contractor on this project, and we took on the full M&E package. So the penstocks, 3 by 3 meters, the 5 big ones. There's one small 1.8 by 1.8, which was used for fish passage reasons. But also we took on the hydraulics, the HPUs, the full control system. Yeah, so full turnkey. And when I mean electrics, even the water boiler, you know, the big kettle, even that we had to supply. So literally the contractor said, if it's electrical, if it's mechanical, that's in your scope. So you can see the size of these units during the installation when we were putting them in. They're big. I mean, 3 by 3 meters, you're driving a big pickup truck through there. This is the completed project. You can see the big hydraulic cylinders that were installed to operate each of the gates. And then we come to St. Germans. So St. Germans was actually with the same tier 1 contractor and very similar reasons. So this was back in 2010, so actually before Morpeth. But at the time, until recently, it was our largest project. For ACE, the value was 1.4 million. Now, St. Germans is the biggest pumping station in the UK. It's the second biggest in Europe. It's got a capacity of 100 cubic meters per second. And the contractor came to us and said, well, we were one of 2 bidding parties, but we were offering a stainless steel solution, whilst our competition was offering mild steel. The end client had worked with us, used stainless steel for various places, and thought, actually, for a big pumping station like this, I don't want to be pulling the doors out. I don't want to be respraying them. I don't want to be shot blasting. I don't want to be carrying out that maintenance. I want a maintenance-free solution as much as absolutely possible. So he leaned towards the stainless steel solution, which we had to offer. So that included 6 4 by 4 meter penstocks, all hydraulically actuated, 6 4 by 4 meter sets of non-return valves, which we did in a tiered system to make it as hydrodynamically efficient as possible for the pumps. Then we put the mild steel stop logs. They were mild steel because they would be stored. They're not always in the water. And carried out the full installation, and all the hydraulics up to the point of the HPU. The controls were delivered by another party, but still, in terms of turnkey, it's a 1.4 million project, and one that we're very proud of. It's also great when you've got a project that you've installed 10 years ago of this kind of size that you can show customers around. They see it, everything's working. They ask the end client, how much maintenance do you have to do? And he says, yeah, basically nothing. It's just absolutely quality. So that leads us into our current largest project. So at the moment, we've got a project of just over 2 million to supply six variable speed fish-friendly pumps. Each pump's got a capacity of 4 cubic meters per second and a lift of 6 meters. So really big units. I mean, the motor on there is 330 kilowatts. It's got 10,000 Newton meters torque. So that's almost 8 or 9 Mercedes AMG 6.8 litre engines in one pump. It's a serious piece of kit for a torque comparison. At this particular project, we also had to dewater, so we complete turnkey installation of the stop logs, which are on the inlet, and that was be able to gain access to carry out the survey to design the FSI. So this particular project had a similar issue as Appledore, in that it was a end suction pump, and because it was an end suction pump, it's got a very shallow sump. So the contractor wanted a fish-friendly pump, or the end client, the Environment Agency, wanted a fish-friendly pump with a submerged impeller. They didn't like the end suction pump because you've got problems with vacuum pumps and their reliability. So they wanted this kind of setup and this solution. And once again, because of the CFD modeling that we could offer, we could show that it was very likely to work. However, to make 100% sure, we needed to set the inlet dry, which is why we installed the stop logs. And then also, of course, measure out in detail the inlet there. It's very difficult because it's not nice right angles you're working with. This is a square shape which slowly transforms into a pipe. So very difficult to capture. So after we install the stop logs completely with divers, we set it dry and we could go in and do a survey. And I'm going to hand you over to James now. James, are you there?
Yeah, I'm here. Yeah, it's probably best if you can share the screen now, Martin, and I can have a look at I can show the model that we achieved.
Yeah, I will just quickly make you presenter.
Okay.
You should be driving.
Yeah, if you just bear with me 1 second. That's the screen. There we go. So basically what we were able to do, I'm hoping everyone can see my screen now, is we ended up coring a hole in the top surface here, and then lowering a 3D camera into the sump here. Now this model that you can see on screen is the physical model that they produced from the laser scan that we had done. But what you can see is there's so many curves and bends and organic kind of shapes that to do that by hand would have been a nightmare, and it would have been quite difficult to get to the kind of tolerances that we need. I mean, just to give you an idea of how much accuracy we've got, you can even see what was left over in the bottom of the sump of the silt that couldn't be removed. So this is the accuracy, or the level of accuracy that we get from this, is to within about 5 millimeters. I did have a photograph this is a photograph from the actual survey, so you can obviously see you can actually see more on the drawing than you can on the photograph. And from our point of view, for producing our engineering drawings, it's such a powerful tool that it allows us to have, to get exactly what we need and build it on the screen. Okay, I'll hand that back to you now, Martin.
Very good. I'll just get the presentation back up. Can you see that, James?
Yeah, we can see that, Martin.
Excellent. Yeah, so Yeah, really clever stuff. Nice innovation being used at Keadby. One of the reasons that we got the contract, really the main reasons were we had the best evidence of fish friendliness. The Environment Agency look at our CFD modelling, the reports we produce, the vast amount of monitoring that's been happened on our pumps, and it's unquestionable that they're going to be more fish friendly than any alternative that was there. The fact that we could do the CFD modelling to that kind of degree, the fact that we could produce an FSI that was going to be prefabricated rather than one that was needing casting in, which is what the competition wanted to do, which is very difficult in a damp and wet environment. And one where also we could use new motor technologies, permanent magnet drives in particular, that were a lot lighter. So the craneage inside this building is limited to 5 ton, and an induction motor of that size would typically weigh 12 ton. However, by the use of PM motor technology, we could produce the same power and torque in a unit that only weighed 3.5 ton, which meant that you didn't need to replace the whole overhead gantry cranes and everything else. But as I say, innovation is what we do. If you've got difficult challenges, we love to take a look at that and see if we can help come up with a nice solution. So I hope you enjoyed listening to some of the case studies. I hope it gives you a nice flavour of what we can do. We're not just installing in the dry. If you need us to do lifting, if you need us to do dive works, if you need us to provide a complete package, complete with electricals and control systems, we can do all of those things. If you need us to carry out detailed surveys, even if it's a survey inspection, just to give you an idea of different options that we could take going forwards. They're all things that ACE can offer. We also have off-the-shelf products. Now, the off-the-shelf pen stocks, don't forget you can make what we call a sort of mini turnkey project. If you want the pen stock with an actuator with a control panel and we put it together as a package, that's something that we can certainly do. We can also come and install them. So hope this has given you a nice flavour. And if anybody's got any questions, now's the time to ask. Nope. Okay, well, thank you very much for joining us. And hopefully we'll see some of you next week. Next week is going to be a webinar about fish monitoring systems. And that's particularly off the back of the very popular Fish Passage Solutions webinar. So thank you. Hope you have a great weekend, considering the virus and everything. But cheers.
Thanks, everybody.
Cheers, James. Bye.